A very good morning, students. Today we are going to discuss about the solution of exercise 1.3. Those who have not watched the introduction of this exercise 1.3, so you are requested to watch that video to get the better understanding of this. So question number 1 is prove that root 5 is irrational number. So we will start the solution in the similar manner, by the contradiction method only. Let root 5 is rational. So if root 5 is rational, then root 5 can be written in the form of p upon q, where q is not equal to 0 and p and q are co-prime. We will consider I have already told you that any rational number can be expressed in a unique way if the numerator and denominator are co-prime numbers. Now squaring both sides. So square of root 5 is equal to square of p upon q. So square of root 5 means what? Root 5 is basically 5 raised to the power 1 upon 2 whole square. So it can be 5 raised to the power 1 upon 2 into 2. So that is equal to 5 raised to power 1, that is 5. So we can write root 5 whole square as 5 and it will be p square upon q square. Now we can write p square is equal to 5 times of q square, which shows that 5 and q square are the factors of p square. That is, we can say that 5 divides p square. And by the theorem we know that if 5 is a prime number, if any prime number divides a square of an integer, then that prime number will also divides the integer itself. Now again, if 5 is the factor of p, so let the other product of other factor of p are c, then let p is equal to 5 times of c. Again squaring both sides, we get p square is equal to 5c whole square. Okay, so here if I take p square is equal to 5q square as equation number 1 and p square is equal to 5c whole square as equation number 2. So in the equation 1 and 2, from equation 1 and 2, we can see that the LHS are equal, left hand side are equal, so RHS will also be equal. From equation 1 and 2, we can say that since LHS are equal, so RHS will also be equal. 5q square will be equals to 5c whole square, that is 5q square, q square is equal to square of 5, that is 25 c square upon 5. So we can simplify it. 5 5 is the 25, that means q square is equal to 5c square. Okay, so again this indicates that 5 is the factor of q square, that is 5 divides q square, and by the theorem that if any prime factor divides the square of an integer, then it will also divides the integer itself. So this shows that 5 is the common factor 5 is the common factor of p and q. Okay, that means this contradict the fact that p and q are co-prime. P and q are co-prime. Thus, therefore, we say that the assumption that root 5 is rational is wrong. Therefore, root 5 is irrational number. Hence, okay. Now, second question, prove that 3 plus 2 root 5 is irrational. This will also be done with contradiction method, but slightly in a different way. Let 3 plus 2 root 5 is rational number. Then 3 plus 2 root 5 is equal to P upon Q, where Q is not equal to 0 and P and Q are co-prime. Okay. Then now if we take this 3 to the other side, so 2 root 5 will be equal to P upon Q minus of 3. Okay. So it will be 2 root 5 equals to LCM Q times of 1, product of denominators, then product of crisscross, that the denominator of the second fraction multiplied by the numerator of the first fraction minus denominator of the second fraction multiplied by denominator of the first fraction multiplied by the numerator of the second fraction. So it will be 2 root 5 is equal to P minus 3Q upon Q. Now root 5 will be equal to, since this 2 is in multiply, so it will become, to the other side it will become divide, so it will be P minus 3Q upon 2Q. Okay, and clearly it is clear from here that P minus 3Q upon 2Q, since clearly, or since, you can use any phrase, since this is rational number, so we can say that if this term, that the left hand RHS, right hand side, is rational, then LHS will also be rational. So root 5 is rational. So root 5 is rational. This will contradict the fact that root 5 is an irrational number. We have just proved in question number 1 that root 5 is irrational. So that means the assumption is wrong. The assumption which we have taken, that 3 plus 2 root 5 is rational, is wrong. Therefore, we say that 3 plus 2 root 5 is irrational number. So similarly, the third question, prove that the following are irrational. Part number 1, that is 1 upon root 2. So in the similar manner, let 1 upon root 2 is rational. So 1 upon root 2 is equal to P upon Q, where Q is not equal to 0 and P and Q are P and Q are co-prime. Okay. Now by cross multiplication, Q times of 1 is equal to P times of root 2. So we can say that root 2 is equal to Q upon P. So here, since the denominator is also coming P, so we have to take one more assumption. This is very important. We have to take assumption that P is also not equal to 0. Why? If we have not taken this assumption, then what will be the problem? Problem will be this, that if P is 0, suppose, then Q upon 0, it will be not defined. Okay, so that's why we have to take this assumption also, that P is not equal to 0. So clearly we can say that if P upon Q is a rational number, then Q upon P is a rational number, also a rational number. So root 2, since RHS is rational, so LHS will also be rational, is rational. And if root 2 is rational, this contradicts the fact that root 2 is irrational. Therefore, we say that the assumption, above assumption, is wrong. Therefore, 1 by root 2 is irrational number. Understood? Okay, second part, that prove that 7 root 5 is an irrational number. In the similar manner, we'll start. Let 7 root 5 is rational, contradiction method only. So 7 root 5 is equal to P upon Q, where Q is not equal to 0 and P and Q are co-prime. If you do not take P and Q are co-prime, then also the question will be correct. But I not doing that, because so that you do not confuse. You may confuse that where you have to take P and Q co-prime, in which question you don't have to take P and Q. So it is rather take P and Q co-prime in all type of questions. Then there will be no confusion. So now root 5 will be equal to P upon 7Q. So clearly we can say that P upon 7Q is rational. Therefore, root 5 is rational, which contradict the fact that root 5 is irrational. Therefore, 7 root 5 is an irrational number. Now part number third, 6 plus root 2 we have to prove irrational. So again, let 6 plus root 2 is rational. Then 6 plus root 2 is equal to P upon Q, where Q is not equal to 0 and P and Q are co-prime. P and Q are co-prime numbers. Then we can say that root 2 is equal to P upon Q minus of 6. Okay, clearly P upon Q minus of 6 is rational. So root 2 is rational. This contradicts the fact that root 2 is an irrational number. Therefore, the above assumption is wrong. So 6 plus root 2 is irrational. With this we have completed the exercise. Thank you so much.